Next thing we need to learn in 4.3 here is how to use our trig identities. You're going to use these a lot over the next few months, or at least some of you will. Remember, you have the sine of theta is equal to a 1 over cosecant. Cosecant is equal to a 1 over sine. Cosine is equal to a 1 over secant. Secant is equal to a 1 over cosine. And then you have tangent is equal to a 1 over cotangent. Cotangent would be equal to a 1 over tangent. Now another thing to remember is your quotient identities. Tangent is equal to a sine over a cosine because you have your y over your x. Cotangent, since that's just a reciprocal, that is an x over y. And then you have your Pythagorean identities, and I will go over these a little bit more in depth in class next time. But these are going to be used to prove some identities and to just use some of our algebra skills and be able to prove some of our theorems we have to prove here in a little bit. Alright, well, none of that really applies to what we're going to be doing here, except in the directions it says we need to let theta be an acute angle such that cosine of theta is equal to a 0.96, and then it says we need to find the values using trig identities. Well, we need to find your sine of theta. Well, if cosine of theta is a 0.96 over 1, then what we need to do is we need to draw a triangle. And so here's one. So here's our triangle. And if we let this angle be our theta, cosine is a 0.96 over 1, which is equal to your adjacent side over your hypotenuse. So if we find out that our adjacent side is equal to a 0.96 right here, your hypotenuse is a 1, then to find out this other side, you're going to have to use the Pythagorean theorem to figure out what your opposite side is going to be. So we need to say 0.96 squared plus, we don't know what this is, so we'll call this our y, or we could call it our, and we could call it an O for opposite side, but that'd be a little more confusing. So we're going to do 0.96 squared plus our y squared is going to equal our 1 squared. So if you take a 0.96 and you want to square that, it's 0.9216. So we get 0.9216 plus y squared is equal to 1 squared is just 1. Subtract this to both sides. 0.9216 minus 0.9216. So then we get y squared is equal to whatever 1 minus that is. It's at 0.0784. 0.784. And then we got to take the square root. So if you take square root of 0.0784, so 1 minus point, let me double check my math here. And if we need to take a square root of that, so second square root 0.0784 gives us 0.28. So y is equal to a 0.28. So that means that this side is 0.28. And if you remember your sine of theta, that is just equal to your opposite side over your hypotenuse. Remember, so you end up getting a 0.28 over your hypotenuse of 1, which is just a 0.28. There you go. Now, what we're going to be able to do is we're going to be able to use that same triangle for finding your tangent. Your tangent of theta is just equal to your TOA, so opposite over adjacent, which is going to give you your opposite side from this angle here. This is your opposite side. This is your adjacent side. You're going to be able to take a 0.28 divided by 0.96. And since these are some ugly decimals, we're just going to take 0.28 divided by 0.96, which gives us a pretty decimal of 0.29 and we'll just round to 0.29. So the tangent of theta would just be a 0.29. So the big thing about this problem is you need to take the information that's given to you, draw your own right triangle, and you're given two of your sides. You just have to use the Pythagorean theorem to find your third side, and then you can go in and find all of your different trig identities.